So let's try to algebraically evaluate some limits. Now, if you evaluate the numerator and denominator at x equals 3/2, you're going to get 0 divided by 0. Now, I assume you've read your limit laws. It is the case that the limit of a ratio is the ratio to limits as long as both these limits exist and as long as that denominator is non-zero. But it is 0. And so this limit law does not apply. As a matter of fact, it's worse than that. I get a 0/0 situation when I try to evaluate this limit. I sometimes refer to a 0/0 situation when I try to evaluate the limit as an indeterminate form. There are others, but we'll get to those. So if I evaluate a limit and it is in this form, then I simply panic. And when I say panic, I mean I just try to massage the expression within the limit any way I can. Do you mind if I double check my arithmetic? Aha, I'm glad I can check my arithmetic. Okay, I like it. Notice how when I canceled these two factors, upstairs and downstairs, what I really did was I eliminated the problem child for this limit because it's this expression as well as this one that does evaluate to 0. And so having removed the problem child, now when I plug 3/2 in for x, I get something meaningful upstairs and downstairs, and the denominator is non-zero. Here, I'm taking the limit of a compound rational expression. When I plug 4 in for x, I get 0/0 situation again. But because this is compound rational, I will play my typical math D game. Here's my version of panicking. Now you can say that this is illegal because technically speaking, when I plug 4 in for x, this is not defined, so this is not always equal to 1, but it's a limit. I don't care what happens when x exists. And so it's assumed that I'm multiplying by this expression for any value of x other than that one. Now paying the consequence of that red action. Oops. Do you mind if I double check all my arithmetic? Okay. Now notice in this example, it certainly is a case that as x approaches 4, my numerator goes to -4. But as x goes to 4 downstairs, it goes to 0. So I get a -4 of a 0 situation. It's not a 0 of a 0 situation, but a non-zero number of a 0 situation. So my question is this. Given that that means that x equals 4, I have a vertical asymptote. Which one of these 4 behaviors do I have, graphically speaking? I'm too lazy to draw the graph, so I just do this. Locally speaking, about x equals 4, that's negative. But notice that with the squaring, it's always positive. And so clearly the behavior of the curve is as such. I've evaluated my limit. Oh, by the way, the textbook might say this limit does not exist because this is not a finite fixed real number. But I want you to write this because it tells the reader that on the graph of the equation y equals the original expression in the limit, the corresponding y value decreased up bound as x approaches 4 from both sides simultaneously. So you might see it does not exist in the book. I want to see this.